do that. Is it recording? It is recording. Okay, so work is a force times a distance. Remember that we defined that as a transfer of energy. So this is the notion. If I do work on this mass, if I push it from here to here, you got to watch. This is like, you guys are like looking down at your video screens. Here, look up here. Okay, so if I go like this, okay, I've done work on it. I've exerted a force over a distance, right? Have I given this energy?
Yes. Yep.
Yes, indeed, I have given it potential energy. It now has potential energy that it didn't have before, right? That is positive work. I gave this thing energy. Now, if I take it from up here, it's like up there, and I move it to here, have I given it energy? No, I've actually taken energy away. So that whole thing about negative work that I talk about is fairly important. IB likes to test you whether you know positive or negative work. If you're taking energy away from something, it's negative work. If you're giving it to something, it's positive work. But specifically, remember, if the force and distance are in the same direction, it's positive work. And if they're opposite directions, it's negative, right? Okay, kinetic energy, a hammer. Regard the hammer. It is a subtle device, right? This is an energy storage unit. Superman just takes nails out of his pocket and just goes and sticks them in like push pins, right? Hey, there we go, right? Okay. But the rest of us, we take a hammer and we exert a force times a distance on the hammer, right? Yeah? I exert a force times a distance. It gains kinetic energy. And then what does it do when it hits the nail?
It releases it.
It exerts another force times the distance. So a hammer is actually a crude mechanical advantage. I'm exerting a small force over a large distance, yes, small force over a large distance, and then when it hits that with all of its kinetic energy, it exerts a large force over a small distance. Yeah? That's kind of crazy, isn't it? Okay? And then springs, let me show you an actual spring in action. I know that the little curly lines that I drew,
They were amazing.
right? Yeah, no, I was trying, but you know, there it is, right? So here's an actual spring. What we are looking at, keep in mind that we're only going to look at simple springs. There are springs that are not simple. If you become an engineer, you can design, basically, you could write what you want the force curve to be, right? Our springs have a force curve that's linear, and that's all we're going to do, right? So if we do force versus distance, it's a straight line. But you can, as an engineer, design a spring that has any force curve you want, right? So it could go, and they have these on like trucks and things. Yeah, you could have gradually, like leaf springs, I think, have some curve like that. I could be wrong, I don't know, right? But that's the notion. So with a linear spring, just watch this. This is what I'm talking about, is that as I stretch it, watch what happens to the force. And technically, I'm pushing it this way. The force is actually that it's exerting on me is that way, right? Okay. So that's really all that didn't translate into blue pen land very well. And so let me hit stop on this.